recall, our goal when we are doing programming is we keep in mind this principle, keeping it short and simple. And one way to achieve this is to do declarative programming using lambdas and streams. This will help us to keep our programs concise and shorter. And for imperative programming, that's what we have been doing so far. What we have seen so far is mainly imperative programming, where us as developer, we tell the program how to perform certain tasks, how to do the actual algorithm. In declarative programming, we don't need to specify the how. We just specify what we want and let the compiler work out the how. So this makes our code much more concise and makes our program much more clearer to understand. So to achieve this declarative programming, also known as functional programming, we need to use lambdas. So a lambda is nothing but very similar to a method. So it can take some parameters, it does some work in the body of the lambda, and then returns some value. So that's what a lambda is. Yes, please.
Why is it so written that lambda is a function?
Because it has some differences. Yes. What are the major differences?
I know the differences, but it is a function.
Yes, but it is a lambda because it has function. You cannot do function must have a name. That's what you have seen. Lambda is anonymous. This problem I already explained it to you before. For humans, they are excellent. So this is what we do perfect, is naming things. So we always name it. Even something is slightly different, khalas, we give it another name. So it's a lambda, because why is it a lambda? Because it is a function, but it has some properties not in the normal function. So it's no longer just a function. We call it a lambda. That's basically the idea. So it is anonymous. It's not belonging to any object or class. It's just flying freely. And more importantly, I can pass it as a parameter to another function. That's the power of lambdas. I can pass them as parameter to another function. And in terms of syntax, this is how I write it. I put the parameter and this arrow symbol, and then the body of the lambda. That's how it is done. And I might use them, especially with filters and map, as I will explain shortly. So now lambdas by themselves are very useful, but they become even more so when you combine them with streams. So a stream, again, is a sequence of objects that we can apply some functions to those streams, such as map, filter, reduce. So those functions, especially in Java, they are not available directly on a list. I have to first take a list, make it a stream, and then apply those functions to the stream. Now those functions, like let's say map and filter and reduce, they take as a parameter a lambda. So that's the connection between the lambda concept and the stream concept. And the power of these streams also, I can ask the system to do the computation in parallel. In this case, if your system if the CPU of your system has multi-cores, you can ask the Java runtime to distribute the work over multiple cores to speed up the process. And in terms of implementation, it's very simple. All you do, you go to the stream, you do dot parallel, and then you ask it to filter or map or reduce, and the runtime will do it in parallel. So that's another advantage of using streams. And in fact, we can go to any list, any collection or any list, and we can convert it to a stream very easily by going to the list.stream, and this will produce for you a stream. And then based on that stream, you can call this very useful map, reduce, and filter functions. So that's the concept of a filter. The concept of streams. Now the streams, the reason why they are so useful is that once I have a stream, I can apply some very nice methods that the stream provides for me to process elements of the stream. I can either do some transformation to the element using map or I can filter elements that meet certain conditions using filter, or I can find elements using find, or I can collapse all the elements using reduce. So I just want to quickly review this visually, just for you to keep them in mind while we're going through the examples. You can visualize what this operation is trying to do. So when you see filter, you have a list, and then you pass it through a filter, and that filter will only let out the elements that meet certain conditions. So you put some condition there. If the element meets the condition, it will make its way in the output. Otherwise, it will be ignored. That's what filter operation does. Now, the map operation, you have one list, and you want to transform it to another list. For example, you have a list of numbers, and you want to square them or double them. You can do so. You have a list of strings, and you want to convert them to uppercase. You can do so. So you can transform every element in the list. You produce another list with the transformed element. That's what the map allows you to do. The other interesting function that we heavily use when you use strings is you can reduce a list to a single value. You can collapse the whole list and squeeze it into a single value, such as going through these elements of the list and summing them all up. So for example, visually the way it will look is that you have some initial value, you add it to the first element, you get the results, and then you add it to the subsequent elements, and you keep doing this until there are no more elements in the list. And when you finish this, process, you have one value from the list. This is called reduce operation. Those are the main ideas. Last one I want to show you, although I will explain it through examples, is when you finish processing your stream, you can put it back again into a list. This is called collect the results into some kind of bucket. So you might be doing a lot of work, and then when you finish, you can put it yet in another list. This is called collection of the results. And I use this operation dot collect, and I will explain this through examples. That's conceptually, that's all there is to it. There's the concept of a lambda, which is a function that I can pass as a parameter to another function. And there is a string, there's a sequence of values, and I can apply some operations to them, such as map, reduce, filter, find, collect. That's all, in terms of concepts. Now, in terms of, you need a lot of practice, you need a lot of examples to see the value of these lambdas and streams, so you can start using them. Whenever you find yourself using loops, you come back and say, no, this is an old-fashioned way of doing it. Let me do it in a more declarative way. I will make use of streams, make use of lambdas. But that will take a bit of time, a bit of practice. And that's why I'm jumping now to the examples that I already provided, and I'm keeping updating them. Hopefully by the end of today or this weekend, you get the final version. So I'll go through some of the examples. I cannot go through everything. So some of the examples, and you go through the rest of them. Okay. Also, some of you, I'm not sure, many of you are not turning up to the tutorials. There are also tutorials you can go to on Thursdays and Wednesdays. That could be also helpful. Okay. All right, so this example, we already seen it, but I will just go super quickly over it, just to as a refresh, and then go through some new examples. So here it is. I have a list of numbers. By the way, this is how I create a list. Super easy. I go to the list class and say of, and then start putting my list, my numbers, comma separated values. This will give me a list of integers. And my goal here is I just want to loop through them and display them. That's what I want to achieve. If I use traditional imperative style, I will tell the program how to do this. I will tell the program, by the way, go through and visit every element in the list by using a loop. And by the way, you need a counter. Initialize that counter with 0 and go through every element from 0 to size -1. Once you reach the size, exit the loop. That's what I'm specifying here how I will display. So there is the counter. I initialize it with 0. I check the condition. As long as I is less than the size, I keep doing this. And not to forget to increment the I, otherwise I'll end up in infinite loop. And then I'll display the element at position I. That's one way of doing it. If you want a little bit more sophisticated, you go into the for each loop, the enhanced version of the loop that comes with Java. In here, I don't have any counter. I just say for every element in the loop, go through and display. That's a little bit better than the first version. But even there is a better one. This is now starting to become more declarative than imperative. In here, I just say for each, go and print. I'm not giving you any loop, and I was giving you how to do it. I'm just saying to you, for each element in this loop, for each element in this list, go ahead and print it. So for each is a method that comes with the list. A list has a method called for each. And what does for each take as a parameter? What does it take as a parameter? Lambda. That's a new word you should use. Don't tell me it takes a function. What does it take as a parameter? Lambda. Where is the lambda? Where is it? I cannot see it. Here. This is the lambda. Does it have a name? It doesn't have a name. It's a function. It does not have a name. It just has the parameter and what I want to do with the parameter. Okay? I can, of course, put here, by the way, I can put here integer. If I wish, I can put integer here and do it this way. But this is, the compiler will be laughing at you. Say, I already know this. Why are you wasting your time? I already know you told me that this is a list of numbers. I will not find there's something surprising. I will only find numbers. So don't save yourself some typing. Keep things nice and concise. Okay, and just tell me what you want. Basically, tell me what you want me to do for each of those elements in the list. That's all. In the most concise possible way. Yeah. Now,
the data type to a different data type?
in here, your imagination is the limit. In here, what you can do, you can put, if this line is not enough for you, you can basically open the curly braces, and what you have there, the whole Java is there, and the whole imagination is there. You can do whatever you wish. There's no limit here. But the idea is, in here, because I only have one statement, I don't need to put curly braces. I just put it, okay? But there is even some guys that I call it lazy boy. I usually don't call them lazy girls because girls are usually more active. Okay, even this one, they find it too hard or too long. Okay, you can make it. Okay, say this is E. I'm repeating it here again. And why should I put this arrow? So can I just remove this E? And the compiler will say, what you talking about? And say, oh, I'll keep you happy by replacing the dots with 2 columns. So this one and this one, exactly the same. Yeah, that's it. This is the meaning. This is the shortest possible version you can do. All I'm saying, it's almost plain English. Saying, let's go through every element and print it. That's what I want, not how. Internally, you work out, the compiler will work out. For example, here, doing multiply by 2, for example. Yeah, I cannot use this, of course. In here, this is only useful. No, not to print. It can be used for other things. We will see. It's only useful if you are using the input, giving it to the method without any other things. What I mean?
One method, if I'm applying one method on.
Yes, only one method. If you want to apply more, I told you, if you want to apply more, open your curly brace. Yes. and basically and start putting here. Let me just show you. If you want to put multiple statements, for example, I can put here int doubled, and I'll print out this. Yeah, I can put multi-lines. I can put whatever I want to do. But of course, this cannot be that cannot be collapsed into this. Yeah, this is a special case. This version here is a special case if you are just taking an element and throwing it at print to print.
Can I make like n double this the whole line? Can I make it in the previous one?
The previous one? Yes, yes, of course.
And then just one double.
You mean I put it here, inside here? Yeah. And put, so, yes, I can do, of course. What do you mean, like do the transformation before I come to the print?
No, like, this is the last line.
Mm-hmm.
The last line here.
Yeah.
I can just use this without this whole thing.
No, this one, as I mentioned, this kind of shortening the lambda into this is a special case when you have when you take the input and put it as a parameter to a method without any further processing. It's a one-to-one. The E, I take it and print it. Then you can summarize that lambda into this syntax. But if you are doing more than that, then you have to keep it as it is. You cannot further summarize it. Yes? Okay. This is just a taste. There is more stuff coming, the very exciting stuff coming. Is clear? The first step is clear? Okay. This is the second example I want to explain. Here is another list. Again, I do list of and put my numbers, comma, delimiter. In here, I have a different goal in mind. What I want to do, I want to get the even numbers in this list, double them, and then do the sum. That's what my goal. So I want to filter the even ones, double them, and do the sum. 3 steps. Of course, I can do it the imperative way, where I will teach the program and the computer how to do it. How to do it, I initialize a result with 0, look through every element of the array, and say, are you, this element I am looking at, are you even? Yes. I'll take that even number, multiply it by 2, and add it to the result, and keep doing this until I go through all the list. So this is imperative style, telling the computer exactly how to do it. Now, with the lambdas, you can do a little bit more than this. You can do better than this. You can basically do it in a declarative way. Declarative way means the way I explain what I want to do, I write the what. I don't write the how, I write the what. What was the tasks I want to do? I want to filter only the even numbers, double them, and sum them. Yeah, exactly what's going on here. So first, because this is a list, for me to be able to do filter and map and reduce, I first need to make it a stream. So I go to the list and say list.stream. This will make it a stream. And then to filter, I do dot filter and give, what is this? A lambda. So this lambda gives the filter. The lucky elements where this condition is true, they will make their way to the output. The unlucky ones that don't meet this condition, they will be discarded, ignored. Now, what I want to say, let me visually put these ones, because this is important. I want you to really understand it. Okay, so here is my stream. Stream is sequence coming towards you, flowing towards you. It's like, imagine your hose, I told you. The stream is nothing but you have your tap and you plug your hose and The water just keep flashing out. This is what a stream is. You have basically a list. It was sitting nicely, comfortable, and suddenly the stream came. Stream takes all the values and push them in a sequence. That's what a stream is. And then here, what I have here, I have like a filter. And what this filter says, okay, here, the filter says, if it is divisible by 2, I let you go. Otherwise, I will just discard that element. Yeah, this filter acting like the security guy at the door, at the university gate. Okay, people who have stickers, they are allowed. People not have stickers, do your turn and go back from where you came. Okay, that's what the role of the filter. So what the filter takes as an input? Stream. What does it produce? A stream. Thank you. That's the idea. Okay. Now that stream, once I finish with it, once I took it through the filter. Some of them made it, some of them were dropped, and now I can take it through another method. In this case, it's not a filter. I can put it through another filter if I wish. I'll say here, oh, please give me the ones that are even and greater than 4. I can do it in 2 filters, but this is not very good. I can just put it here if I wish. Yes, and E greater than 4. Yeah, I can do that. Or I can put it in 2 filters. It's up to me. Okay, so the ones that will make it out of this filter will go into the map. What the map will do? Transform every element. In this case, what transformation are we doing to every element? What transformation are we doing to every element? We're doubling them. Okay? Okay, so when I double them, what map takes as an input? A stream. What does it produce? A stream. Very good. That's it. So I take a stream and produce a stream, and this stream will go into the third operation, which is the reduce. Now the reduce, what the reduce will do? One value. Collapse them into one value. Because I'm doing the sum, basically the reduce, how many parameters the reduce takes? Remember, the reduce is a method. So it takes parameters. What are these 2 parameters it takes? Yes, that's the initialization value. Yes, that value is used to initialize what? The sum in this scenario. Yeah, because why did we choose 0? Why not 1? No, because n plus 0 is equal n. Because 0 has no impact on the addition. That's why we started with 0.
So doctor, we can replace some with another.
Yes. If we wish, for example, if I want to produce the product of these numbers, what do you think this will look like? So we have to start with 1. If we put 0, then the whole thing will be collapsed to 0. And that's not what we want. And all I do here, instead of sum, I will call it product. And in here, instead of sum, I call it product. And instead of plus, multiply. And this will do the product of these numbers. Yeah. So reduce, I'm not limited to sum. I can do any operation I wish. But in all cases, the reduce, the way it works, I have some initial value that will be assigned to this value here, to the product. And then the initial value of product will be 1. Then I'll take 1 times the first value in the string and produce a result. Then I'll take that result, multiply it with the second value of the string, and that result, I'll take it, multiply it by the third element, and keep going until at the end of the day, what I will have at my hand? 1 value, which is the product. So the reduce, what does the reduce take as an input? A string. What does it produce? 1 value. Does it produce a string? 1 value. Now, can I put any extra operations after the reduce? Can I do filter, a map? That's it. Because the reduce is called a terminal operator. Terminal operation. operation. So once you call reduce, خلاص. There is no more stream produced. So we stop there. Is clear?
Can
Okay.
we work
Yes,
with like multiple elements from the same stream at once?
multiple elements on the same stream at once. Usually one element at a time, except when you are comparing or when you are comparing. We will see this later. But usually one element at a time. Yes, one element at a time. So filter to filter, map to transform, reduce to collapse. That's what we saw so far. Yes? Yes,
And
please.
we just choose operators, we can't use like conditions.
No, because remember, every method has its own mission, its own role. Yeah, if you want to filter, if you want to basically filter element that meet certain conditions, use filter. If you want to transform elements, use map. If you want to collapse them, use reduce. So everyone has very specific, clear role to play. Is clear? Okay. Which method you talking about? Okay, very good. Those are built-in methods. It's not our methods, yes? Those are built-in. Remember, filter, map, and reduce. Did we create them ourselves?
No.
They are built-in as part of the Stream API that Java provides. Us as developers, what do we provide to these operations?
The stream is
What do we provide? The stream and
Lambda.
the lambda. Thank you very much. We provide the stream and lambdas. So us as developer, we become like lambda developers. We just write lambdas. That's what we do. We don't create loops anymore. That's the idea. Okay, this is one way of doing it, but because I am dealing with numbers, there is a better way of doing it. Similar, very similar. So instead of saying map, there is another special version of map called map to int, which is no surprise. It will be producing a list of integers. So I can call dot sum. I don't need to do the reduce myself. I can do the sum. I can do dot average. I can do dot sum average count and so on. Yeah.
This only works with the map to int.
This only works with map to int. Yes, I tried it. This is a good question. By the way, these questions I like them, but I like you to take the examples and go to these questions that come to mind and try them. Change things and try to see how it behaves. Okay, so if I just use to map, the sum is complaining. The sum is saying, oh, I cannot work with stream of integer. Anyway, it doesn't like it. You need to make it a really simple integers. You need to say map to int. Yes? Then it's happy. So this version and this one are equivalent, exactly the same. Okay, but of course this one is much more elegant, much more simple. And I'm only putting it in multi-lines because to make it easy to read. This is the recommended way, by the way, to put them in multi-line. But this could be one line. The whole thing could be one line. Okay, moving on, there is another example here, very exciting example. Here it is. You see here in this file, I have here the list of countries of the world, all the countries on the world. Yeah. Now, if I am curious for some reason, I want to know which countries in the world have their name, the length of their name, greater than 3 and less than 5. Greater than 3 characters and less than 5 characters. Yeah? So first of all, take a look at this. The data that I'm manipulating will be coming from a file. Although we will spend 1 week just dealing with files, but now I just want to give you a small taste of how I deal with files. Very simple, by the way, in Java. All I do, I go to this class called files. This is a built-in class in Java. It lives in this package. Can you see the package? java.nio.file.files. And then I'll say .lines. Go through make those lines in the file, make them a stream, make them coming to me like a water from a hose. That's what I'm asking what I'm asking this file to do. Please go to this file and keep shooting at me those lines. Yeah. So this will give me what? Stream of strings. And what will be in this stream of strings? The name of the countries. Yeah. Because it is a stream, I can use now my filter and my reduce and my find, and I can use all those nice functions. Okay, so here I say filter, please give me only the names, only give me the countries where the length is greater than 3 and less than 5. Yes? And I want you for this will produce what? This filter, what the filter will produce? Another string. Yeah? And then I will say for each element in that stream, all I am doing here, printing it. This should not scare you now. Yes, it's clear. Okay, that's it. So now if I run this, these are the countries of the world where the name is greater than 3 and less than 5. Yeah. Okay, now, if I'm not interested to see them, I don't want to see them, I just want to count them. So for counting, I don't need to reduce. All I do, sorry, just a second, dot count. Yeah, that's it. This will give me int count. If I just want to count them, I don't need to do reduce. Any problem here? This is long. It returns a long, not an int. It returns a long, okay? The count returns a long. And then basically I can display the count if I'm interested. Yeah? How many countries in the world where the name is between 3 and 5? 12 countries. Yeah? It's clear? So the source of the stream, the data source where a stream can get their data from, we have seen two sources so far, a list or a file. Yeah. At least in this course, we will just limit ourselves to this. So the stream, I can connect the stream to a list, and then the elements of the list will be shooted one by one. While they are sequenced, I can apply some functions to them. File, the same thing for the file. I can connect stream to it and say, start shooting all the lines of the file towards my program. And then while they are coming, I'll apply some conditions, some methods to them. Like in here, we applied the filter method. Yes? It's clear? Now, when you apply some when you apply some methods to the stream, some of the methods, they produce another stream. And that's why you will be lucky, and then you can apply more methods. For example, you can do dot filter, dot map, and do another dot map, no problem. But there are some methods that are terminal methods, terminal operations, like dot count. Dot count returns a long. That's it, no more. You cannot apply more operations on the string.
Does it have to be a long? Can we say an int?
In here, like this is how they have designed it. So the count is a method. It returns long. So we have to, if we put integer, it will not accept it, because long is much longer, because you might have a big stream with a lot of elements. If you put it in an int, you might lose some of the data, because long can accumulate a much larger number. So that's why we have to respect.
Why did you close the stream?
Okay, very good, very good. Why did I close the stream? Basically, the stream, when I'm dealing with the file, I have to explicitly close it. Yeah, we will see this later So the stream, because the file belongs to the operating system. Remember, who manages files? The operating system. So here, when I'm saying file.line, I'm asking the operating system, please go to this file, start shooting at me the lines of the file. Okay? When you are done, I'll ask it, please close the file. If you don't close the file, it might remain open. You know, sometimes you try to delete some file and Windows will tell you, sorry, I cannot delete it, it's in use.
Yes.
This is an example. If you don't close and your program is running, nobody can delete that file, change it, because you are using it. That's why when we finish, that's a nice gesture. We tell the operating system, please close it so others can take over control of that file. That's why we close it. Okay. Going on, here it is, another one, collect. What does dot collect does? What's the role of dot collect? It's basically when I do some processing, if I care about the results and I want to put them in some bucket to use them later, I use the dot collect. Okay, so let me show you. Here we have exactly the same goal. Remember, we have exactly the same goal, which is going through this list, filtering the even, doubling them, and doubling them. Here, just doubling them, okay? Now, and when I double them, what I want to do, the results, I want to put it in a list. So the results of this filter and map, what will be the result of this filter and map? It will be 2 times 2, 4. 4 times 2, 8. 4 again, and 8. Yes? That's what we will see. So we'll see 4, 8, 4, 8. Okay. So this is a naive way of doing it. I create a list, which is the double of evens. I create a list myself, and then do for each, and for each elements, for each even number that was doubled, I add it to this list. So when I finish this stream processing, I'll have all the results in this list. That's one way of doing it, of course. But a more elegant way of doing it is just to use this, instead of doing for each and doing it yourself, you just use for dot collect collectors to list. What this means, I want you to get the results and basically put them for me in a list. Yeah. So what you see here, this code here and this code is equivalent, but this is the more elegant way of doing it. Yeah. Let me run it and I will try to explain it further. Okay. So this print double of even, this is what it produces. So this, you remember, the filter will give me the even numbers, the map will double them, and the collect will put them for me in a list. Yeah. Now you can see here there is some repetition. What if I don't want this repetition? I just want 4 and 8. Luckily, there is another operator called distinct. This will eliminate duplicates. So if I run this, you get, because I didn't do it in the first one, I get 4 and 8, but I did it in the second one, I didn't do it in the first one, so I get duplication. If I want to get rid of duplication, all I do, dot distinct, and this will give me the values that are not repeated without repetition. Yeah. Another way of doing it, this is the best way of doing it, but another way, I can do collectors to set. What's the difference between a set and a list?
Set does not allow multiplication.
Yes, set does not allow duplicates. So if the set has 4 and 8, and you try to add another 4, another 8, it will not be added because the set already has those values. That's another way of doing it. He's using a set instead of a list. So either you use this way, or the most common way is to use a distinct and then collect to a list. Is clear? The concept of collect is that, because remember, the stream is something that similar to, I give you the analogy of hose in your garden. So you put it on in the tap, you turn on, and then the water start coming out, okay, streaming out. Now, if you stream it out, if it reaches the ground, khalas, you cannot reuse it. Especially with the heat, the ground just absorbs it very, very quickly. Now, if you care about that water and you want to use it for something, what you should do, capture it and put it in some kind of bucket. Otherwise, don't expect it to be there, because a stream, remember, the stream does not store anything. Stream is not for storage. Stream is just for taking some list or some file and pushing it as a sequence towards our methods. Yeah. So if we care about the results, what should we do with the results? Collect them in a list or in a set. I can also collect them in a map. Let me show you what this means. Here is the gender enum. Remember the gender enum? Here is the person. We have some person here with the name, gender, and age. Okay. And here, what I have here, I create a list of people. This is how I create a list. I do a new list of and start creating instances. Can you see it? This will create a list of objects. And then I take this list of objects, I stream it, and then I'll collect. You can see here collect. Now when I'm collecting, I collect to what is known to a map. A map is basically a data structure that has a key and value. So this is a map, is data structure that has, you can think of it as a table that has the key and a value. Yeah. So in this case, for example, the key could be the name. Let's say Sarah and the age 20, Ali, age 18. In this case. So I want to produce from that list of objects, I want to produce a map. What is the key? The name. And the value? The age. Yeah. And it's some kind of table like this. So that's what I'm doing here. So if I go here, I'll say, please go ahead and collect, but I want you to collect as a map. Collectors to map. What is my key? The name. And what is the value? The get age. Now when I display, if I right click here and I run, you can see here I get a map. Here is the key and here is the value. Here is the key and here is the value. Okay. So that's another way of doing it. This is very useful. It can be very, very useful. If you have a list of objects and you want to convert them to a map, you can do so very easily.
It produces a list, right? This is a list.
This is a list, but special kind of list that has a key and a value.
Yeah. I was about to ask, like, lists hold only elements of the same data type.
Okay, yeah. Here, it's a list that, think of it as a list with two columns, key and value. Yeah. Now I can, of course, before I do this, I can filter. I can filter, let's say, remember the filter? Dot filter. I only want to get the people, or where P dot get age is greater than 20. Yeah, I can do that. And now when I run this, I should only get the people with greater than 20. You see, this is very, very powerful. So I'm filtering and then collecting to a map. Okay. Okay, find. Here is find. You have this list here. What's my goal here? I want to find, given a list, find the double of the first even number greater than 3. So here is a list. I want to find the first even number greater than 3, and I will double it. That's my goal. Of course, I can do it imperatively. Here is the results, what I'm looking for. I loop through the list and I'll ask, is the element greater than 3? Is it even? If yes, I take that element, double it, and break from the loop, because I only want the first one. Yes? Now, a better way of doing it is using the streams. So you see what I'm doing here? Numbers dot stream, and I filter. I'll say filter the ones that are elements greater than 3 and even. And then I map Why did I do the map?
We doubled
We doubled it. Yes, we doubled. And then I'll find here the first. Find first. Yeah. Now this I might not have any number here that is even. I might not find what I'm looking for. For example, if I put here greater than 300, do I have any number here greater than 300? No. So the results, that's why the results will be, it's a bit weird the way the Java people did it. The result will be optional, the data type will be optional integer. Optional integer means it could be there, it might not be there. So they put it optional integer. Interesting. And then, interesting API, they say if present, then it is there. Can you see here? If present gets value, else say no value. Yeah? So let me just run this. What do you think now? We will get what? No value because double of first. No value because this is the first loop, of course, found a value. Yeah, I just need to put it here. Okay, that's one way of doing it. A better way of doing this, let me show another way of doing it. In here, find first or else 0. That's another way of doing it. Duplicate integer, and this is my number. Yeah. So you can do it this way. You can do optional integer, okay? Or you can come here and say find first. Else, if you don't find it, you put the default value, or maybe -1 or whatever. But I think in this scenario, this is much better. This implementation is much better. You do the data type. The only difference here is you do the data type instead of putting int, you put optional int, which means I might find what I'm looking for. I might not find what I'm looking for. Now, once I exit the stream, then I go to the answer and ask the answer. Is present means I found what I'm looking for. Then I go ahead and say answer.get. This will give me the value I'm looking for. Otherwise, I will say I didn't find it. Yeah. In here, I do or else, which means if you don't find it, assign 0 to this number. Yeah. If I have okay. If you have some default value, this one works very well. If I have some default value, I can say find me the first or else return the default value. Last one. Here is can you see here list of countries? I am filtering the countries where the length is greater than 10. Yeah. So what I can do here, I can do filter, find first, else or else none. Yeah, the country where the first will be none. Yeah. So it's up to you. Either you do optional, and then you check if it's present, or you just come to after you do find first, you do or else, and you put a default value. The value that will be assigned to the variable if no match is found.